Hey Fox, welcome to the next video in this series, Hive coding. So we are seeing the problem minimum element in sorted and rotated array. The problem statement says that there is a sorted array with distinct elements and it is rotated at some unknown point. The task is to find the minimum element in it. So let's look at an example. So this is an array, and as we can see that this 4 and 5 they are in correct order, 1 2 and 3 are in correct order, but these two segments are not. So this array has been rotated. The original sorted array 1 2 3 4 5 has been rotated by 3 positions. So let's see how to code it live. So let's analyze the input first. The first line of input contains a single integer t denoting the number of test cases, then t test cases follow. So the standard online judge style. Let's do it. So let's code up the first few things that are needed. Our main function, the entry point, okay, so we'll be using the scanner here so that we can easily scan the input. Let's see how many test cases we have and store that number in this variable. For each test case, we will be running a function that is going to find the output for that test case. So each test case has two lines. One is the number of elements in the array, and other is the all the elements in the array in that order, in the given rotated sorted order. So okay, and now let's get an array list. Okay, and let's populate our array list. Okay, now at this point of time our current array variable will be storing the reference of the array where we have all our elements stored. Now let's call the method that is going to do the real magic. Let's call it find min in rotated sorted. Okay, so before we start coding, let's see some examples and recognize the pattern. So we can have a array like we can have another array like, and we can have an array like. Okay, let's have a few more elements here. So there are three cases. We are going to apply binary search to this. What we are going to do is we select a pivot element, the mid. So if we see this array, 2 is our mid element. So we'll compare the first element 7 with 2, and if 7 is greater than 2, that means there is an inversion. That means there is a pivot point which is in this area, in this subsection, in this sub array. And if it is not the case here, then we ignore this. So we use the divide and conquer approach, and we divide the array into 2 sub arrays, and we figure out by comparing the first element and last element of both the sub arrays that how to which sub array to recurse into. So let's see, let's code it up. Okay, so first let's write some base cases so that we can handle the cases when there are no elements in the array, there is one element in the array, and there are 2 elements in the array. If there are no elements in the array, let's return -1. An error code, else if there is one element in the array, let's return that element. Else if there are 2 elements in the array, let's return the min of both of them. Alright, so now let's pivot this array. Okay, and now we are going to compare the first element and the mid of first sublist, and the second, and the mid and the last element of the second sublist. Current array dot get 0, that is the first element of the current array, is greater than the middle element. That means we need to recurse in this part of the sub array, and in that case we write zero to mid okay. So the sublist method excludes the last element, and we want to include it here. That's why there is a +1. The next is the second case, else if current array else if current array dot get mid is greater than this array dot last element. Then we recurse into the another array, the second part, and that starts with mid, and ends with current array dot size. Okay, and the other case is this one, and there is no rotation in the array. In that case we are going to just return the first element. Okay, so we have coded this up. Let's try to run it and see if it works. Okay, great. So it works. It's a simple problem. It's a problem of binary search. There is a little extension, and it's the standard divide and conquer approach for solving problems. Thank you.